In this video, we're going to talk about how to draw a slope field and how to match it with the appropriate equation. So let's talk about slopes. If we have a slope of 0, what does that mean? A slope of 0 represents a horizontal line, which looks like this. Now, if we have a slope of 1, we have a line that's going up at a 45-degree angle. And if the slope is 2, it's going to go up at a higher angle. Now, if the slope is -1, it's going to go down at an angle of 45 degrees. And if it's -2, even more so. Now, what about if the slope is very large, if it's a high number? Then you're going to have a vertical line. Or if it's undefined, you still will have a vertical line. So these are some things that you want to keep in mind when drawing a slope field. So let's start with a practice problem. Let's say we have the differential equation y prime is equal to x. Go ahead and draw the slope field that corresponds to this equation. So let's make a table. We're going to have x, y, and y prime. Now, y prime doesn't depend on y. It only depends on x. So there's nothing that we could put in this column. When x is 0, y prime is 0. When x is 1, that's going to be 1, and so forth. So how can we plot this? What does it mean? So when x is 0, the slope is 0. Y prime gives us the slope values. So x is 0 at the origin. So we're going to draw, I'm not sure what just happened there, but we're going to draw a horizontal line at 0. Now, y could be anything. Y could be 1, 2, 3, 4, 5. So since y prime doesn't depend on y, anywhere where x is 0, we're going to have a slope of 0. So at this point, x is 0 as well. That's the point 0, 1, and at 0, 2, x is still 0, so the slope is 0. So whether we go up or down, the slope will be the same. Now when x is 1, which is anywhere in this region, the slope is 1. So now we need to draw a line with a slope of 1. And then when x is 2, the slope is going to be 2. Now on the left side, when x is -1, the slope is -1. And when x is -2, the slope will be -2. And so this is the slope field that we have for this example. Now, if we draw a line, we can get one of the solution curves. And so we can see that the general solution has a parabolic shape. Now let's solve the differential equation. Y prime is basically dy over dx. Now let's separate the variables. So let's multiply both sides by dx. So we have dy is equal to x dx. Now, let's find the antiderivative of both sides. The antiderivative of dy is y, and the antiderivative of x is x squared over 2, and then plus some constancy. So we could see that 1/2 x squared has a parabolic shape. It opens upward, which is in harmony with this graph. So the slope field can give you a good idea of what the shape of the solution to the equation should be. Now let's work on another simple example. So let's say y prime is equal to y. Go ahead and plot the slope field that corresponds to that equation. So let's make a table. So notice that y prime does not depend on x. So we don't need to put anything in that column. So when y is 0, y prime is 0. So y is 0 anywhere along the x-axis. So at every point, we're going to have a horizontal line. Now, when y is 1, which is anywhere in this region, the slope will be 1. And when y is 2, the slope will be 2. And then when y is negative 1, the slope is negative 1. And then it's going to be negative 2. So to plot the solution of the differential equation, it should look something like this. It appears to be going in that direction. And that looks like an exponential function. Now let's go ahead and solve this equation. So let's replace y prime with dy over dx. And just like before, we're going to multiply both sides by dx. So we're going to have dy is equal to y times dx. And then divide both sides by y. So on the left side, we have 1 over y, dy is equal to dx on the right side. So now we can find the antiderivative of both sides. The integral of 1 over y is ln y. And the antiderivative of dx, or 1 dx, is x plus c. So now we're going to put both sides of the equation on the exponent of e. So we're going to have e raised to the ln y is equal to e raised to the x plus c. Now e to the ln y, the base is e, and so this simplifies to just y. And e to the x plus c. Let's say if you have x to the 7, you can write that as x to the 3 plus 4, because 7 is 3 plus 4. And then you could separate it into two parts. That's x cubed times x to the 4th. So e to the x plus c can be written as e to the x times e to the c. And e to the c is a constant, so we can replace that whole thing with a constant. So the solution is going to be y is equal to c e to the x. And exponential functions have the general shape that looks something like that, which is what we have in this example. So once again, the slope field, it gives you a good shape of the solution to the differential equation. Now let's move on to our next example, where y prime is x minus y. So this time, y prime depends on two variables as opposed to one in the last two examples. So this is going to be a little bit harder to graph, but we're going to follow the same process. So let's start with 0. When x is 0 and y is 0, the slope is going to be 0. Now, notice that when x is 1 and y is 1, the slope will also be 0. When x is 2 and y is 2, the slope is 0. 2 minus 2 will be 0. So notice the pattern that's forming here. So continuing the pattern, anytime x and y have the same value, the slope will be 0. And you want to look for patterns because it helps you to quickly plot the slope field. Now, what is the next pattern that we can identify? So what about when x is 1 and y is 0? When x is 1 unit higher than y, 1 minus 0 will be 1. So we're going to have a slope of 1 at this point. Now what about when x is 2 and y is 1? 2 minus 1 is still 1, and so the point 2 comma 1 is here. And then the next point 3 comma 2, 3 minus 2 is 1. Now if we go backwards, this will take us to the point 0, negative 1. And 0 minus negative 1 is still positive 1. So then this point where x is negative 1 and y is negative 2, that's still going to give us a slope of 1. And so the pattern will continue. Now let's try the next point. Let's try 2 comma 0. So 2 minus 0 is 2. So the slope here will be 2. And then if we try the next point, let's say 3, 1. 3 minus 1 is still 2. So we can see the same thing that's happening. Now what about this point? Let's make a new table. So when x is 0 and y is 1, 0 minus 1 is negative 1. So this is going to look like this. So this point here should be the same thing if it follows the pattern. So when x is 1 and y is 2, 1 minus 2 is still negative 1. So now that a pattern has emerged, we can just continue the pattern. Now let's focus on this point. When x is 0 and y is 2. So 0 minus 2 is negative 2. And so this is going to look like that. And then I imagine at this point should be the same. That's when x is 1 and y is 3. 1 minus 3 is still negative 2. And then after that, we can see that the slope is becoming more negative. So the next one should look something like this. It's going to be almost vertical. We could just fill it in at this point. And it's not going to change. Now, continuing this trend, if we plug in this point where x is 3 and y is 0, the slope is going to be 3. So it's going to be almost vertical at that point. And then after that, we could just draw vertical lines because that's going to be the trend in this region. So now we have a good estimate of the slope field that corresponds to this differential equation. And it turns out that the solution, or at least one solution that we can draw, is this straight line here. So notice that one of the solutions to this equation is a linear equation. Now, if you want to know how to solve this differential equation, how to integrate it, there's another video I have on YouTube entitled First Order Linear Differential Equations. So if you watch that video, you'll be able to see how you can solve that differential equation. And so what you need to do is put it in the appropriate form, which is going to be y prime plus y is equal to x. Now once it's in standard form, the video will show you what to do from this point. So I'm going to give you the solution to the differential equation, and you can verify it that it is indeed a solution. So the solution is y is equal to x minus 1. And you can see it here. This graph, you can see the y-intercept is negative 1. So that point is 0, negative 1. And if you plug in 0 for x, you're going to get negative 1 for y. 0 minus 1 is negative 1. So the solution passes through this point. Now we can verify that this is indeed the solution to this differential equation. If we calculate y prime by taking the first derivative of this function, the derivative of x minus 1 is going to be 1, and the derivative of negative 1 is 0. So this is y prime. Y prime is 1. So let's plug in y prime and y into the differential equation. So y prime is 1, and then we have x minus y, where y is x minus 1. So this is going to be x minus x, and then negative times negative 1 is plus 1. These two will cancel, and so we can see 1 is equal to 1. So therefore, this line in red represents the solution to the differential equation, which is y is equal to x minus 1. Now, here's a multiple choice problem, and we're given the graph of the slope field, and we need to match it to the appropriate equation. Now, what you need to do is pick a point and see if that point works for each equation. So let's focus on this point. At that point, x is 0, y is 1, and the slope, notice that we have a horizontal blue line, so y prime, the slope, has to be 0. Now, let's look at answer choice A. If we plug in these values, will y prime be 0? So y plus x, that's going to be 1 plus 0. 1 plus 0 is 1. It doesn't equal 0, so we can eliminate answer choice A. Now, you want to eliminate every answer until you get the right answer. Now, let's move on to answer choice B. So x is 0, y is 1. Negative 0 divided by 1 is 0. So far, B is okay. It works for that point, so we won't eliminate that answer. Now, let's move on to part C. Y is 1, x is 0. So this is 2 over 0, so it's undefined, which means we should have a vertical tangent, not a horizontal line. So we can eliminate answer choice C. Now, moving on to answer choice D. Let's plug in the same points. So y is 1, x is 0, and so this is going to be 1 plus 0, which is 1. So we need a slope of 0, not 1. So that would correlate to a blue line that looks like that. So D can be eliminated. So the right answer is B. That is the differential equation that corresponds to this slope field. And so you just got to plug in points, and then you can match it with the right equation. Now, looking at the slope field, what type of graph do we have? Notice that we have the shape of a circle. Now, you can have a big circle, or you can have a small circle, but the general shape is a circle. Now, let's solve the differential equation. So let's replace y prime with dy over dx, and so that's equal to negative x over y. And let's cross multiply. So we're going to have y times dy, and that's equal to negative x times dx. So now let's integrate both sides. The antiderivative of y is y squared over 2, and the antiderivative of negative x is negative x squared over 2 plus c. Now I'm going to take this term, move it to that side. So I have x squared over 2 plus y squared over 2. That's equal to c. Now, let's multiply both sides of the equation by 2. So the 2's will cancel, and so we'll be left with x squared plus y squared, which is equal to 2c. Now, 2c is a constant, so we could just replace that with c. So this is the general solution of the differential equation. Now, x squared plus y squared equals c. What equation does that look like, so to speak? So notice that this equation is identical to the equation of a circle, which is x squared plus y squared, and that's equal to r squared. And r represents the radius of a circle, which is a constant for a specific circle. And so for this circle, we can see that r is equal to 2. So for that red line that I drew, if r is 2, the solution of that particular equation will be x squared plus y squared is equal to 4. Now let's say if I drew the circle here. So notice that the radius is 1. So this will correlate to this particular equation, x squared plus y squared is equal to 1. So the constant c can change, depending on if you're dealing with a small circle or with a large circle. But nevertheless, the general shape is still a circle. And so that's it for this video. Hopefully it gave you a good introduction into slope fields, how to graph it, and how to match it to the appropriate equation. Thanks for watching.